Okay, part 2. We're going to look at some more advanced equations and solving them. One of the types will be the radical, could be the nth root of some variable expression, and it's equal to a variable. And this particular one is going to be some sort of number plus, you may have a number outside of here, but plus some sort of variable expression equals a variable expression. They have two different types. These types of equations, we really have to make sure that we don't have extraneous solutions. Remember, extraneous solutions are solutions that don't work. So we need to check for that. So we're going to do example number 1. Example number 1 is something like this. The square root of 56 minus p equals p. So we're going to approach this the same way. We have the radical isolated all by itself, which is what we want. And we're going to go ahead and square both sides because that's how we get rid of a square root. And once we do that, we get p squared equals 56 minus p. Now I have a p and I have a p squared, so I have only a few things that I can do. I can factor it, I can complete the square, I could graph it, find the solutions. It's however you want to go about doing it, but I do need to get it all on one side. So I'm going to go ahead and add p, and I'm going to get rid of my 56. So I end up with 0 equals p squared plus p minus 56. I could graph this. If I graphed it, I would get my two solutions right away. Or I can factor it, or use quadratic formula. I know that this factors. It's going to be 8 and 7. It's going to be plus and minus. So p could equal 7, or p could equal negative 8. Remember, we set each of those equal to 0. Now, this is where I need to check. And when I plug in, so here's my check step. When I plug it in, is the square root of 56 minus 7 equal to 7. Square root of 49 equals 7. That works. All right, so now let's look at this one. Is the square root of 56 minus negative 8 equal to negative 8? Well, can a square root ever equal a negative? Just a plain old square root ever equal negative? No. So that one does not work. So my solution has to be just 7. It's the only possibility. All right, I'm going to give you an example, and then I'm going to pause the video. I want you to go ahead and work the example, and now I'll come back to where you have it worked out. So, example number 2 for this type is going to be something like this. 27 equals, this one. X equals the square root of negative 3 plus 4x. So there's your problem. Go ahead and pause the video, work through it, and then come back. I am going to pause the video and then work it out, and then I'll show you these. All right, I'm going to very quickly show you what I did. So we square both sides. We square both sides, it doesn't mess with the stuff under the radical or the radicand. It's just the radicand equals x squared. And so I'm going to get rid of my 3. I need it to get it to equal 0. So that's what these two steps were. I'm going to factor it. If I had graphed x squared minus 4x plus 3, or if I had graphed in Desmos x squared equals negative 3 plus 4x, I would get 1 and 3 as my solutions. I plug them in to check and make sure both of them work, and they do. So that is my my first problem type. Second problem type goes back to some number or stuff outside the radical, and I have a variable inside the radical, and I have it equal to a radical. So we're going to look at this particular problem. Let's do this one. Example number 3. And this is type 2. That's not an official, that's just how I group them. So if I had a square root of 2b plus 8, and that is equal to 1 plus the square root of 3b minus 3. Now, these two radicals I can't combine. If I could, I would, but I can't combine those, and I've got a 1 plus. So I need to have one radical by itself, and then I'm going to square it. So I'm going to go ahead and square this. And then I'll end up with 2b plus 8 equals, all right, so now when I square this, it's going to be a little bit gnarly because I have 1, I have this 3b minus 3, I have 1, and I have the square root of 3b minus 3. So 1 times 1 is 1, that's easy. The square root of 3b minus 3 times the square root of 3b minus 3 is 3b minus 3. That's easy, because I'm just squaring it. Now, 1 times the square root of 3b minus 3 is 3b minus 3. 1 times the square root of 3b minus 3 is 3b minus 3. So now I've got, well, my 1 and my negative 3 could go together, and that's going to give me a negative 2. So I have negative 2 plus 3b. That's just putting those two groups together. And then I have two radicals. I have plus 2 times the square root of 3b minus 3. So let's review what I did there. So I squared this. I can't just square the 1 and square this. I have to square the binomial because there's a plus in the middle, which makes it a binomial. So 1 times 1 is 1. 1 times the square root of 3b minus 3 is the square root of 3b minus 3. But I have another one, so I have two of them. That's where I got 2 times the square root of 3b minus 3. And then if I add these together, I get 1 plus negative 3 is negative 2. And then I have my 3b. So step 1 is to square both sides. Now I need to go and move everything over to one side except for that radical, because I'm going to have to square it again. And if I have the radical in with another number, it's going to create another radical. So I need to get everything to the other side. So let's simplify this guy a little bit. I'm going to add the 2. I'm going to go ahead and get rid of my 3b. And then I end up with negative 1b plus 10 equals 2 times the square root of 3b minus 3. Alright, you have a couple choices here. You could, I would say, probably divide it by 2. That's just my preference. I'd like to get that completely by itself. Since there's no plus or minus here, I could square both sides first. I'm going to go ahead and divide both sides by 2. And what I do to one, I have to do to all. So I have negative b over 2 plus 5 equals the square root of 3b minus 3. Now I'm going to square both sides. Okay, that finally got rid of the radical, but it kind of created a nasty situation on this side. So I have negative b over 2 plus 5, negative b over 2 plus 5. I need to multiply those together because it's a binomial. I have a variable plus a number. 5 times 5 is easy, that's 25. negative b times negative b is positive b squared over 4. 5 times negative b over 2 is negative 5b over 2. This is negative 5b over 2. Now let's put it together. So I have 25. I have b squared over 4. Now negative 5b over 2 plus negative 5b over 2 is negative 10b over 2. Negative 10 divided by 2 is 5, so b minus 5b. Alright, now I have to get everything to one side so that I can go ahead and solve it. I could also graph it at this point in Desmos. I'm probably going to go ahead and just solve it for you. B squared over 4 minus 8b plus 28 equals 0. I don't know about you, but I'm not interested in dealing with the 4. So I'm going to multiply everything by 4. Ugh! I think I'm going to Desmos for this one. Plus 28 and 4 would be, well, we know 28 times 4 is going to give me this number. Be a 32, 112. And the reason I wrote that to the side is because I know 28 and 4 gives me 32. So those are my two factors. Oh, not 32, 28. 4. So my solutions are 4 and 28. Now, this beastly problem, I definitely need to check my work and make sure that both of those solutions work. I'm going to pause the video and check that. Alright, so when I checked this, the first one worked. 4 worked. 28, however, did not, so then my solution has to be 4. So let's kind of just summarize what we did here. So the first thing that we did was we squared both sides. We squared both sides, but we have a 1 plus a radical. So it's a binomial, so we have to square it like a binomial. Then I got rid of everything except for the radical. And that's where I got down to here. And then I squared both sides again. That finally got rid of the radical. Pulled it all over to one side, factored it, got my two equations. I'm going to give you one more problem. This is the most difficult problems that you'll have. If you have any, it will only be one of them. So I'm going to give you one more problem to try, and I'm going to pause the video and then I'll come back with the solution. So your next problem to try is going to be this one. Square root of 3 minus p minus the square root of 3p plus 3 equals negative 2. Now, notice this isn't set up with a radical equals stuff, so we do need to get a radical all by itself. Otherwise, when we're squaring, it's not going to be super pretty. So we're going to go ahead and pull this radical to the other side. That's my hint to you. And then I want you to go ahead and go through that process that we did on the last problem. Alright, I'm going to pause the video, you work it out, and then come back and check out the solution. Alright, so here's my work. So the first thing we did, we already did this part. We squared both things. Over here is how I squared them. And then I got everything over to one side, which gave me 1 plus p equals the square root of 3p plus 3. That worked pretty. I squared both sides. Once I squared both sides, pulled everything over, factored it, I got negative 1 or 2. Negative 1 in my check step did not work, but 2 did. So 2 is my solution.